and tangent lines. So we've done stuff with rate of change before when we've looked at like slope, obviously on a more basic level. But if we're finding the average rate of change over an interval, basically we're finding the y value of the function like at the initial point minus the final point minus the initial point. So we're doing like a little bit more math, and then it's over like minus the x values of, or like, let me rephrase, it's an interval. So the interval is like from 0 to 2. So we'll be evaluating it at 2 minus evaluating it at 0, and then we'll be doing over 2 minus 0. So it's easier to see with an example anyway. So 2, I've got f of x is equal to the square root of 4x plus 1. And then they want us to do it over 2 different intervals. So the first one is the interval from 0 to 2, and they'll be closed intervals because obviously we need the endpoints for them. So we'll do the square root of 4 times 2 plus 1. I made that square root so large. And then minus the square root of 4 times 0 plus 1. And obviously when you're plugging in like a 0, I don't care if you actually show that or if you just get rid of it. But for right now, for seeing it, I'll put it over 2 minus 0. So that gives me, let's see, 8, 9. So square root of 9 is 3 minus square root of 1 is 1 all over 2. So that ends up just being 2 over 2, which is 1. So the rate of change at that value is 1. The second interval they give us is from 10 to 12. So obviously still a gap of like 2 here because between 0 and 2 and then 10 to 12. But it's not going to give us, in most cases, you won't get the same value. So we're just doing the same thing but with these numbers. So this is the square root of 4 times 12 plus 1 minus the square root of 4 times 10 plus 1 all over 12 minus 10. So we've got 48, 49, square root of 49 is 7, minus, we got 40 and 1 is 41. I don't think that can break down at all. 41 is 41 prime?
I think so.
Yeah, I think it is. So I don't think, because I was going to say 3, but then I was like, wait, no, I don't think 3 goes into that. The only number that might is 17, but I don't think it does. No, because 17 times 2. Yeah, no, it doesn't. So we'll just leave this as the square root of 41 and then over 2. And since the radical's on top, we can leave it just like that. Obviously, if you wanted to split it and have like 7 over 2 minus square root of 41 over 2, you could also do that. But this is fine just to leave it like that. Let's look at one with a trig function, number 6. So f of x is equal to 2 plus the cosine of x. And the intervals they're giving us are pretty nice. They're giving us 0 to pi. And then the other one is from negative pi to pi. This is where, like, things like this is where your unit circle, you know, they're not going to ask you to directly write your unit circle in the AP exam, but they still obviously expect you to be able to use it. Fortunately, they don't usually pick super weird values. I mean, 0 and pi, obviously pretty easy, but anyways. So plugging in, we've got for 2 plus the cosine of pi minus, I would put this in parentheses unless you're going to go ahead and change the signs as you write them both, since it's like 2 and cosine. So then 2 plus the cosine of 0 all over pi minus 0. Do you remember what the cosine of pi is?
Is it
Yep. So that'll be a -1, and then cosine of 0.
What?
Yeah. So I've got here, just to rewrite it really quick, 2 minus 1, then -2, minus another 1 because that negative is being distributed there. So all over pi, which ends up giving me negative, let's see what happens if it solves it. Oh, it gives it to me as a decimal. That's disappointing. -2 over pi, and again, fine to leave it like that. Over here on the other one, then we've got 2 plus the cosine of pi minus 2 plus the cosine of negative pi. Well, the cosine of negative pi is going to be the exact same thing as the cosine of pi, right? So those are just going to cancel each other out, basically. Over, I guess I should do this, pi plus pi. So we've already said cosine of pi is -1. Cosine of negative pi would also be -1, just because it's just going in the opposite direction, but still hitting the same spot. So I've got -1 minus a -1, so those just go away. And then I've got 2 minus 2, well, obviously that's 0, and then divided by 2 pi is just 0. It's so blurry. Okay. So the next problems, basically for me, take an entire page because they're like 4 parts. They're not hard, but what I will tell you is you will appreciate this type of stuff in about a chapter when you learn the cheat code of the shortcut to do this. So right now they're teaching you the long method with limits of how to solve these. Once you know derivatives, it'll be a walk in the park. You'll never use this method again after this chapter, most likely. Unless a problem goes through and tells you, like, on, like, the AP questions, sometimes one of them will say something like, use the definition of limits to find blah, blah, blah. That's probably the only scenario in which you're going to use this method going forward. So, anyways, all that to say, they want us to find the slope of the curve, find the equation of the tangent line, find the equation of the normal line, which the normal is just perpendicular to the tangent. Sometimes I hit in physics before I hit in calculus. This time we're hitting calculus first. So you'll have a little leg up in physics when we get to finding, like, the normal. You might remember it from physical science, but, like, when you have the tangent, the normal's perpendicular to it. And then they say to draw the graph of the curve. I don't really usually do that part because it's not a question they're typically going to ask you. So I usually just skip that part. But this problem is 10 y equals x squared minus 4x at x equals 1. So annoying because, like, once you know the shortcut, you're gonna be like, why did you make me do it this way? Because it's like literally I'm sitting here in my head and, like, I already can tell you what the slope is without me even having to do the problem because of the shortcut's that fast. So but it's okay, it's a minor detail. All right, so basically if you remember from, I think you were watching the notes yesterday, there was a formula in there. It's on page 90, but the slope is, the limit is h approaches 0 of f of a plus h minus f of a over h, where a is, like, the point, and then we leave the h in there, because obviously we're dealing with the limit as h approaches 0. So 1 is my a value from that formula, so just to have it for reference here, so I don't have to keep flipping back and forth. The limit as h approaches 0, f of a plus h minus f of a all over h. So basically, what I'm doing is anywhere that I see an x, I'm putting whatever's in the parentheses here, but I'm replacing a with 1 in this like formula set up here. So I've got the limit, and this is just to set up. This isn't even, well, the end of this will get us to our slope, but the limit as h approaches 0 of 1 plus h squared minus 4, oops, that's a plus, minus 4 times 1 plus h, and then minus, I usually use a bracket here since I've had parentheses over there already. I'm just plugging in 1, so 1 squared minus 4 times 1, all over h. So obviously right now, if I just plugged in 0 for h, I have a problem. It's going to be undefined. So your kind of like goal and how you know that you've been successful is when the h's top and bottom cancel. So if I FOIL this, 1 plus h squared, I would get 1 plus 2h plus h squared, and then distribute minus 4h, and then I've got here, this is 1 minus 4 inside of here, so that's negative 3, but then there's obviously the minus there, so it's going to ultimately be a plus 3 from that other part all over h. You're really supposed to write the limit as h approaches 0 every single time. To shorten it, I usually just draw an arrow down and just show that it keeps going down until I get to like my last step, and then I'll do that. So at this point, I'm going to see if anything will cancel out, because obviously that's like the goal, is to get basically I need all the numbers on the top should cancel. That's the beauty of this. And so then you're just left with stuff with h's, and then we can factor the h out. So I've got 1 and 3, which is obviously equal to 4, and then a minus 4, so I can cross all that out. And so then I'm left with a negative 2h plus h squared over h, basically, is what I'm left with. So I'll factor out an h. So I've got h times negative 2 plus h over h. H's cancel, so now I'll rewrite my limit as h approaches 0 of negative 2 plus h. Well, when h is 0, that limit is equal to negative 2. And so this is the slope of the tangent line. And this is part A of the question, is to find the slope. So then the tangent line, we know the x value, right? They told us what x is equal to. I need to find y. So to find y, I'm just going to plug 1 directly into this equation and solve it, which I've obviously already done, technically speaking, in this part right here. So some people will do that part off to the side first, but for part B, for the tangent, I've got the point 1 and f of 1, because we're going to have to use point slope form. Well, f of 1 is 1 squared minus 4 times 1, which we had already said was negative 3. And again, you wouldn't have to write all of this out if you've already done this step up here where you've plugged in the number. If you've written it like I did, where I like went ahead and consolidated it, you wouldn't really have to show this down here. But I'll know that that's negative 3 now. So now I can use this with point slope form to write my equation of my tangent line. And so that would be y plus 3 is equal to negative 2 times x minus 1. It's okay to leave it here. However, well, I was going to say however, it doesn't really matter. You can find the slope of the perpendicular slope without doing anything else. You can leave it here, or you can take it on down and get y equals negative 2x. That's plus 2 minus 3, so minus 1. So either of these would be the tangent line. Obviously, if you need to graph it, it's going to be easier if it's in y equals mx plus b. But in the book probably is taking them all the way to, I don't know. It doesn't have the answers right here. Anyways, up to you. So then the normal line, well, if the slope of the tangent is this and we know that the normal is perpendicular, what does the slope of my normal have to be?
1/2.
Yep. Positive 1/2. And we'll use the exact same point that we had up here. It'll still be 1, -3. That doesn't change. So then I've got y plus 3 equals 1/2 times x minus 1. So again, you can leave it here or take it on down. So y equals 1/2 x, just minus 1/2 minus, is that 6/2? So y equals 1/2 x minus 7/2. So either of those would be fine for your tangent and your normal.
How come you use like the 1 for tangent, the 1, and then the f of 1? Does it like say to use that in the directions?
F of 1 is how I got -3.
Yeah, but like, how come you use that like the 1?
Oh, because they told me that x was equal to 1.
Oh, okay.
So I knew that, which means I have to use,
I see.
I have to find the y value when x is 1. Because it does say at the indicated point. But they're just not giving you the y value. They're just making you find it.
I got you.
Some people do that first, and then where I did up here, the stuff in brackets, they'll just straight up plug the number in if they do that first. I normally just use the formula as is so that there's no like confusion, and then I go through and I fix stuff after. Let's see. So another example of this, 12 is y equals x squared minus 3x minus 1 at x equals 0. So using the formula, the limit as h approaches 0 of f of a plus h, well, that's just 0 plus h for the a plus h part. So if you want to just write h, that's fine. Just make sure that you, if you refer back to a problem, that you look at what the actual formula is supposed to be. Because this would just be h squared minus 3h minus 1. And then minus the second part would be evaluated at 0, which would just be 0 minus 0 minus 1, so -1 in there. And then obviously all over h. So I got 1 minus a -1, so that goes away. Can go ahead and factor out my h. So the limit as h approaches 0, h times h minus 3 over h. I'm shortcutting the process a little bit, but that would then be -3.
Where did the -1 come from in the brackets?
Evaluated f of a. Yeah. So the formula is minus f of a. So I did minus, and then I just plugged in 0 for x everywhere.
Okay.
Yeah. Because this would have been 0 minus 0 minus 1, technically. I just didn't write it all. Which is fine. If you want to write it out, obviously you're welcome to, but most people like to just skip the 0 part. So -3 is my slope of my tangent. And obviously you don't have to write slope of the tangent every single time, but it is, obviously while you're getting used to it, nice to make sure you know what you're talking about. But so that's part A. Part B then is actually finding the tangent line. So we have a slope of -3, and we have a point that is at 0, and then f of 0. But f of 0 I already found up here. When I plug in 0 to this equation, it's just -1. So I could write this as 0, -1 instead. So my equation is y plus 1 is equal to -3 times x well, it's just minus 0, so I'm just going to write negative 3x. And then subtract the 1, y equals negative 3x minus 1. So that's my tangent. So what would the slope of the normal be for this one?
1/3.
Yep. So slope of 1/3. And then obviously still the same point, 0, negative 1. So I've got y plus 1 is equal to 1/3 times x minus 0. So I'm just going to write 1/3 x. And then subtract the 1. Y equals 1/3 x minus 1. And that's my normal. So they're not really hard. They're just kind of time consuming. Especially like in the previous one that we did. Obviously, the limit took a little longer to like get through. 11 will probably be one of the harder ones because it's like in a fraction, but it's still, things should cancel. You may just have to get a common denominator to make things work. So just be aware of that. Okay. What is the next question asking? Oh. Determine whether the curve has a tangent at the indicated point. If it does, give its slope. If not, explain why not. So basically, they're giving us a piecewise function. So in 16, we've got f of x is equal to, got the little curvy brackets, negative x when x is less than 0, and then x squared minus x when x is greater than or equal to 0. And it says at x equals 0. So we're trying to find out if there's a tangent at x equals 0, basically. So to do that, what we're going to do is we're going to take each of these functions individually. So like just negative x and then just x squared minus x. And we're going to see if it produces, basically when I run the limit using that definition formula that I gave you at the beginning. If I do that, is the value, are they equal to each other? If they're equal, then it has a tangent. If they're not equal, then they don't, basically. So for the first one, I'm just going to note here that I'm using negative x. The limit as h, I'll try next, as h approaches 0 of f of a plus h, so that's going to be, and I'm doing, again, a is 0, but I'm going to write it out. So I've got negative 0 plus h minus, evaluated at 0, f of a is just 0. All over h. Then I've got right now, this is, this is going to give me a negative h over h, which I still can't plug in 0. I'd have to reduce it down. So when I do that, I'm left with just a negative 1. So that is the slope of the tangent line for that function. But I've got to do the other one to see if there's actually a tangent at the point for the entire piecewise function. So then the limit as h approaches 0, this one's for x squared minus x. So I've got 0 plus h squared minus 0 plus h. Again, you don't have to write the zeros. Minus, well, that ends up just being a 0 when I put in 0. So, and then all over h. So that gives me, since I have all the zeros, h squared minus h over h. I can factor out an h. So h times h minus 1 over h. H top and bottom cancels. Now I can do the limit as h approaches 0 of h minus 1. And that ends up just giving me a negative 1. So they're the same. Slopes are the same. So we have a tangent. And technically you could just write, because I guess they're technically just asking if it has one, you could just say, yes, slope is -1, and that would be a sufficient answer for what they had. Let's see. Do I want to do that one? I'm going to skip that one for right now. Okay, 24. Find the instantaneous rate of change of the position function y equals f of t in feet at the given time t in seconds. So 24, f of t equals 3t squared plus 2t, and t is equal to 3. So basically, we're doing the exact same thing we've been doing, except for we're just not finding the slope this time. We're finding the instantaneous rate of change. But the formula is exactly the same as it is for what we were doing previously. Well, they changed the letter. So the other one was a plus h. Technically, this one is the limit as h approaches 0 of f of t plus h minus f of t over h, because t is dealing with time. So the limit as h approaches 0 of 3 times, so we're plugging in 3, so 3 plus h squared plus 2 times 3 plus h minus, evaluated at 3 times 3 squared plus 2 times 3 all over h. So obviously this one's going to be a little bit more involved mathematically. So I've got 3 times, it's perfect square trinomial, so 9 plus 6h plus h squared plus 6 plus 2h. Oh, I forgot that minus needs to go around all of that, so I need a bracket. So that's 27 plus 6, 33. So minus 33 all over h. So then multiplying here, that gives me 27 plus 18h plus 3h squared plus 6 plus 2h minus 33 all over h. So this gives me 27, oops, disappeared. 27 and 6 cancel with the negative 33. So on top, I'm left with 20h plus 3h squared. So I'm going to go ahead and factor out an h. And then I'm left with 20 plus 3h over h. H's top and bottom cancel. So the limit as h approaches 0 of 20 plus 3h would be equal to 20. And these had units on them. It said in, what problem is this, 24? In, well, basically feet per second. It doesn't directly say it, but it gives you enough information to figure out that it's feet per second. Oh, that's 20 feet per second there for that one. I was going to stop, but there's literally one problem left, so just go ahead and do the last one. Okay. Free fall, or no, not free fall. Rocket launch. So 28 is at T seconds after liftoff. The height of a rock, or rocket, not rock, is 3t squared feet. How fast is the rocket climbing? After t seconds. Did I say t or 10? Hold on. No, I'm confused. 10 seconds. After 10 seconds. Oops. So basically, my function is this that I'm using, and then this value is x, or t equals, or whatever. I guess I should probably say t for the sake of the formula. So I can find speed this way, how fast it's going with my limit. So I've got the limit as h approaches 0 of 3 times 10 plus h squared minus 3 times 10 squared, all over h. So then I've got 3 times 100 plus 20h plus h squared minus 300 all over h. So I've got 300 plus 60h plus 3h squared minus 300 over h. 300s cancel. I can factor out an h. Now, if you can, I'm always hesitant to let people do this, but if you can take out your h's like this and not actually have to show that you're factoring it out, if you can remember to take it out of all the pieces, that's fine. The only reason I typically make people do it the other way is because they tend to forget. But if you're like, nah, I've got it under control, you can do it that way. So limit as h approaches 0 then of 60 plus 3h would be equal to 60, and we were dealing with feet in seconds, so feet per second for the speed. So basically another way to do your physics problems.
I'm never doing it this way. There's a faster way.
Yeah, there is. Yeah. Basically, when you learn derivatives, so like the derivative of x squared, so if that's the equation, the derivative is equal to 2x. You take the number that's in the exponent and you put it out front, and then you take one away from the exponent. And so then once you do this, you'd evaluate this at the value that you're given, and that's going to be your slope. So like if I did it with this one, so I basically have f of t is equal to 3t squared. So the derivative, f prime of t, would be 6t. I would evaluate this at 10, and I'd have 6 times 10, which is 60 feet per second.
I mean, what the heck?
But that's why I said, like, you have to know how to do it this way, because this method always works. Because if there's a derivative you don't know or you don't know how to find, obviously you can do it with this method. This is kind of like the foolproof method. Like, you know this is going to work. But in chapter 3, literally like by section 2, I think it is, you learn how to do this with derivatives. So it just makes your life so much easier, but you appreciate this so much more when you've had to do it this way, and now like you're like, oh, I have a shortcut.
Yeah.
Because there's some rules, like right now, you wouldn't know how to, well, I guess we didn't have any that were crazy. Some derivatives are harder than others because there's a bunch of derivative rules. So there's some things that you wouldn't be able to do, but they aren't giving you any of those. So anyways, but yes, much shorter process to get to the exact same answer in the end. But that's for next chapter. All right, problems for this section. 1, 9, 11, 17, 23, 25, 27, and 30. 30, just so that you know, the formula that you need for it, because they don't give it to you, is for volume of a sphere is equal to 4/3 pi r cubed. And just so that you know, if you do end up deciding to take the AP exam, that's a formula that like they would expect you to know. Volume of like a sphere, a cone, a cylinder. Those are the 3 big ones that I know right off the top of my head. I mean, obviously like a cube, but I assume you already know that. But these are like some of the big ones that they would expect you to know. But I'm assuming that you probably don't remember them if you have used them before, so I'll try to point them out when I know what they are.